Alex, I spent 3 hours yesterday afternoon scrubbing some 6061 plate with a dedicated stainless brush until my forearm went numb. I felt like a medieval monk illuminating a manuscript, just total devotion to the Church of Clean Metal. And then, I let a gloved finger touch the edge of the joint before I struck the arc.
Let me guess. The puddle looked like a bowl of gray oatmeal the second the arc hit it?
Worse, it looked like the surface of the moon after a heavy rain, just cratered, filthy, and entirely rejected by the laws of physics. That's the thing about aluminum. It's the most sensitive material in the shop. It's got this invisible ego. You disrespect it with one tiny skin oil smudge, and it'll ruin your entire day just to prove a point.
It really is the diva of the welding world. But that's why we're here today. We are doing a deep dive into TIG welding aluminum. It's the mountain every maker wants to climb, but the trail is littered with contaminated tungsten and blown-out edges. Tiger, for the folks who are staring at that AC/DC switch on their machine and feeling a little intimidated, where does the trouble actually start?
It starts with the two-temperature trap. See, the aluminum itself, the shiny stuff, melts at about 1,200 degrees Fahrenheit. But it's wearing a protective suit of aluminum oxide that doesn't melt until you hit nearly 3,700 degrees. If you try to weld through that oxide without the right settings, you're basically trying to melt a chocolate bar inside a ceramic oven. By the time the oven melts, your chocolate has turned into a puddle on the floor.
That's a messy mental image. So that's why we use alternating current, right? The AC flip-flop?
Exactly. We're essentially using the positive side of the AC cycle to blast that oxide skin off like a pressure washer, and the negative side to actually shove the heat into the metal. If you don't get that balance right, you're either not cleaning the surface and getting puddle pepper, those little black specks, or you're overheating your tungsten until it looks like a burnt matchstick.
I've seen you do the dead man's crawl with your hand on the table. You're always telling people to stop hovering their hands in midair like they're performing surgery.
Mapping out your movement is 90% of the battle. If you're floating your hand, you've got no stability. I like to plant the base of my hand, from the wrist across to the pinky, firmly on the bench or a steady rest. You want to slide that hand like it's on a greased rail. If you only move your fingers, you're only going to get an inch of weld before you run out of travel and your torch angle starts getting wonky.
So you're saying move the whole arm, not just the pencil grip move?
Right? Think of it like a ballroom dance. Your torch hand and your filler hand have to be perfectly in sync, but they're doing different jobs. The torch hand is the lead, smooth, steady, sliding forward. The filler hand is the partner, dabbing in, pulling back. The most common disaster for beginners is the tungsten magnet. You go to dab the rod, your torch hand flinches, and zap, you've just welded your filler rod to your electrode.
I've seen the look on your face when that happens. It's a mix of heartbreak and pure, unadulterated annoyance.
It's the walk of shame to the grinder, Alex, every time.
Okay, let's talk about the heat sink effect. I've noticed when you weld aluminum, you start the arc and nothing happens for a second. Then suddenly, it's like a dam breaks.
Aluminum is a heat thief. It'll suck the thermal energy out of that arc and spread it across the whole plate before the spot under your torch even thinks about melting. You have to be aggressive at the start. I usually floor the pedal to get that puddle established, get that shiny wet look, and then the second it starts to flow, you have to start backing off.
It's like driving a car down a steep hill with no brakes, isn't it?
Exactly. The longer you weld, the hotter the whole piece gets. If you keep your foot buried in the pedal, that puddle is going to grow from a nice little dime into a giant silver lake, and then thwack, the whole thing drops through onto the floor. You have to read the puddle. If it starts getting wider than you want, ease up on the gas. If it looks sluggish or cloudy, give it a little more juice.
Speaking of reading the puddle, what about the leading edge? I see a lot of people trying to drop the filler rod right under the tungsten.
Big mistake. That's how you get a contaminated tip. You want to introduce that filler rod to the very front edge of the puddle. The heat of the molten metal should melt the rod, not the arc itself. It's a rhythmic stab and retract motion. If you leave the rod too close to the arc, the end of it will melt into a ball before it even touches the puddle. Then you've got a giant glob of cold metal sitting on top of your joint like a bird dropping. Not exactly the stack of dimes look we're going for.
You mentioned stack of dimes. Everyone is obsessed with that aesthetic. But you've told me before that beauty doesn't always mean strength in aluminum.
Social media has ruined a generation of welders, Alex. People see these neon-colored, perfectly uniform beads, and they think that's the only goal. But with aluminum, you can have a beautiful-looking weld that has zero penetration because you didn't break through that oxide layer, or a weld full of porosity. Basically, tiny gas bubbles trapped inside.
Like Swiss cheese inside the metal?
Precisely. Usually that's from being lazy with the cleaning or having your shielding gas flow set so high. It's creating a venturi effect and sucking in air. I tell people, clean it until you think it's perfect, then clean it for 5 more minutes. Use acetone, use a brand new stainless brush that has never touched carbon steel, and for heaven's sake, don't wipe it with a greasy rag afterward.
I remember you once yelled at me for using a brush that I'd previously used on a rusty tailpipe.
You might as well have been painting the joint with mud. Carbon steel particles embedded in aluminum cause galvanic corrosion. It'll literally rot the weld from the inside out over time.
Let's get technical for a second. AC balance, frequency. These are the pro settings that confuse everyone. Give us the Tiger Shop explanation.
Think of AC balance as your cleanup versus penetration knob. If you've got it set to more electrode positive, you're doing a ton of cleaning, blasting that oxide off, but you're putting a lot of heat into the tungsten. If you go more electrode negative, you're drilling deep into the metal, but the weld might look a bit sooty because you aren't stripping the oxide. I usually find a sweet spot around 70% to 75% DC negative.
And the frequency? The bees in a jar sound?
Yeah, that high-pitched scream. Higher frequency, like 120 hertz, constricts the arc. It makes it like a needle, which is great for thin stuff or tight corners. Lower frequency, like 60 hertz, gives you a wider, softer arc. It's like the difference between a pressure washer and a garden hose. Both have their uses, but you don't want to use a pressure washer to water your petunias.
I love that, pressure washing the metal.
It really is, and you can see it happening. If you look closely at the edges of a good aluminum weld, you'll see this frosty etched zone. That's the area where the AC arc has literally scrubbed the surface clean. If you don't see that frosting, you aren't getting cleaning action, and your weld is probably going to fail.
What's the number one exercise you'd give to someone who just bought their first AC TIG machine?
Don't even try to join two pieces of metal yet. Just take a flat plate of aluminum, maybe 1/8 inch thick, and try to run a puddle across it without any filler metal. Just use the torch. Try to keep the puddle the exact same width from one end to the other. You'll feel the plate get hotter, you'll see the puddle try to run away from you, and you'll have to learn how to dance with that foot pedal to keep it in check.
The pedal dance.
It's everything. Once you can move a puddle in a straight line without it growing or shrinking, then you can start adding the rod. It's about building that muscle memory so you aren't thinking about your hands. You want to be looking at the metal, not your fingers.
You make it sound like Zen and the art of metal maintenance.
It's more like Zen and the art of not melting your shoes. But there is a flow state you get into. When the cleaning action is humming, the puddle is shimmering like liquid mercury, and you're just dabbing along. There's nothing else like it in the craft world. It's the closest thing to magic I've ever found.
Especially when the magic doesn't end with a hole blown through the workpiece.
Believe me, I've got a bin full of magic that didn't quite go to plan. But those are the pieces that taught me the most. Every failed weld is just a map telling you where not to go next time.
So, the takeaway for today? Cleanliness is more than a virtue, it's a requirement. Watch the heat like a hawk, and don't be afraid to floor the pedal to start, as long as you know when to pull back.
And most importantly, keep your tungsten sharp and your rod out of the arc until it's time to dance. Aluminum is a demanding teacher, but once you learn the steps, it'll let you build things that are light, strong, and incredibly beautiful.
Just don't touch it with your bare hands after you clean it.
Never, unless you want your weld to look like it has the measles.
Thanks for joining us in the Tiger Den. Now go out there, grab some scrap, and make some sparks.
And keep those gloves on. Your skin oil is the enemy.